We're gathering for our final COP meeting of 2024, and we're going to talk about machine learning, AI, and parliamentary monitoring. It's a big topic at the moment. Here at My Society, we've been experimenting with ways to include vector search into They Work For You, and Alex is going to talk to us about that later. We're also going to hear from Luis and Billy about their AI experiments and what is working and not working for them. After we've heard from all the speakers, we will have 15 minutes to ask questions and have a bit of discussion amongst ourselves. This is such a new area for so many of us. I think it's going to be exciting to explore the possibilities. And this is also a really big topic for TICTeC 2025, where we're going to dive further into what this kind of technology means for our work. So our first presentation is going to come from Luis Kimaid, Executive Director of Bússola Tech. Luis has been leading the way in the modernization of parliaments in the Americas, and recently they've been working with AI in this field too. Over to you, Luis.
Well, thank you so much for the invitation. Before I start on the topic, just a little bit on our organization. We are a global think tank that works on the promotion of legislative modernization and digital transformation. We do that by promoting peer-to-peer dialogue between staff amongst parliaments and subnational legislatures, in case of the UK, with devolved legislatures as well. We do also a bunch of research around this topic, publications to help stream knowledge resources between parliamentary institutions across the planet. Recently, we hosted 2 months ago a meeting at the US House of Representatives and the Organization of American States around AI and cybersecurity in parliaments. Also, in June this year, a similar meeting that we co-organized at the Chamber of Deputies in Chile. And since last year, we have organized a number of publications that we did in the last 8 years in a digital repository, which is open, which is free for everyone to access. Kindly feel free to use this resource as it fits you. Here, for colleagues interested in this topic, we have crafted a recent publication in partnership with the Association of Secretary Generals of Parliament, the Organization of American States, the Society of the Clerks at the Table in Africa, and the Hellenic OCR team. It's being crafted by us, these organizations, in partnership with a number of parliamentary officials from different countries. Here, a similar perspective, but not a publication, but as a book around AI in parliamentary services, also written by us, by colleagues in different parliaments, in partnership with the Organization of American States, the Commonwealth Parliamentary Association, and local legislative assembly here in Brazil. And finally, to get this regional perspective as well, a similar publication done in partnership with the Society of the Clerks at the Table in Africa, getting the perspective from this particular region around this topic. Well, before I get into the topic of AI in Parliament, I would like to take a step back and to discuss a little bit on the usage of digital technologies and modernization as a whole in Parliament and legislative institutions. As we all know, we need to consider that parliaments are century-old institutions, and they operate under systems and procedures that are decades old. And now we are requesting these institutions to face the challenge of dealing with technologies that change every day. So how can we approach that? We understand that legislative modernization and digital transformation should focus on increasing the effectiveness, the resilience, and the openness of legislative activities in a way that does not compromise the institutional traditions and maintains the equality amongst parliamentary representations, meaning it does not create unequal advantages for specific political groups on using these tools. Centering the modernization strategy on the digitalization of internal and bureaucratic processes, providing more tools for parliamentarians and staff to perform their roles effectively ensures, in our view, a successful transformation process in the institution. What does that mean? It means it creates early wins for the institution to create a political capital for larger projects that transform the institution. Here, very briefly, some considerations on how to tackle the issue of modernization in parliaments. The first one is for the institution to centralize their digital demands on one IT or one technical area. We see that some parliaments, they have multiple areas overlapping and not every time coordinating that often. So it's highly recommended, just like in the example of the UK, to have one centralized department like the Parliamentary Digital Service in the United Kingdom. Secondly, is to develop a document which contains the modernization strategy that addresses the needs from the different business areas, from the institution, and also from the MPs as well. Thirdly, is to use a modular approach to the development on different services, not to try to tackle everything at once, but even in a modular approach, to try to integrate these different modules into one concise digital strategy and vision for the institution. To include staff from these business areas, from Hansa to drafting offices, to committees, to parliamentary offices, and the members as well, and the MPs throughout the development process since the beginning, not to present them with a solution that's already been developed. Well, to establish formal cooperation agreement with other parliaments and legislatures and organizations to promote exchanges such as this one. My society is so brilliantly promoting with you. To ensure agile project tracking, to ensure quick corrections if needed, and different projects. For example, we have the case from the US House of Representatives where they are using agile oversight on their AI initiatives at the US House. Well, keep it simple, and within your capabilities, don't try to embrace the word. It usually doesn't work that well, so try to keep small, try to keep it simple for the institution to be able to tackle the challenge of modernization. To outsource to private solutions whenever it's possible. Parliaments are a representative institution, not a IT company. They are not expected to develop every single system that they are using. To manage the process of change with staff and MPs. And last but not least, to ensure the compliance between the document that contains the modernization strategy with the internal regulations, namely with the rules of procedure and the legislative precedents. Parliamentary modernization requires not only the technological tools, but also the political commitment from the leadership of the institution to ensure that the necessary resources are allocated and structural changes are accepted. What does that mean? It means that the political support should come in a structured way with tangible deliveries. For example, with allocated resources, allocated staff, promoting the discussions when needed about updates in the rules of procedure in the institution. So that should be translated in a concrete way, the political support, be that from the Secretary General, the clerk, the speaker, or the MPs as well. About ensuring the sanctity of the legislative process, we have highlighted 5 principles here on what are the principles of the legislative process that we should uphold, even using digital technologies, be that the social participation, civic participation in the legislative process, transparency, evidence-based legislative process, a legislative process grounded in the legal and procedural frameworks, and lastly but not least, the fair representation of political minorities. Coming to the topic of AI, the use of AI in Parliament must align with the principles and objectives defined by the modernization strategy. The AI strategy should, for Parliament, should be a sub-strategy for the overall modernization efforts. Here, I'm not go through every single one of these topics given the time, However, among the documents I shared at the beginning of my presentation, you can see specific descriptions on how AI is being used on these different legislative areas. Very briefly, for example, enhancer with automatic transcription, with speaker identification, with topic identification as well, if it's a PMQ, if it's a point of order, or any other kind of intervention. On multilingual parliaments, we have voice-to-voice interpretation, namely the Parliament of India is testing that, and given that they have 22 languages that can be used in the legislative debates. Legislative drafting, this is a whole topic that we could stay here the whole morning discussing. Namely, the main focus is not using AI to draft the legislation, but however, how new generative models with retrieval augmented generation grounded in the legislative database, how they can retrieve information that's useful for the drafting and research areas, namely to evaluate the constitutionality or the regulatory impact, and even to manage the amendments on a specific bill or proposal. On historical archives, using OCR technology to digitalize old paper documents, and also to retrieve information using the same technique with retrieval augmented generation. We have here citizen participation as well, on experiences in Brazil, where Google Gemini has been used to categorize, summarize inputs from the civic participation platform, and also to do a profanity filter on these comments being provided by the public. Here, another interesting case is on the procedural guidance, where a similar technique on using retrieval augmented generation can provide clerks and secretary generals with up-to-date procedural advice for them to advise the presiding officer or the speaker of the parliament. And the last one that I would highlight here as an interesting case is on parliamentary expenses as well, with an experience in Chile that I'll mention at the end of my presentation, on the similar technique using retrieval augmented generation for the members and for the public to be more aware of the limitations and possibilities of resources that parliamentarians can make use of. So, for example, a member wants to understand what kind of expense she or he can make in the parliamentary office, or citizens want to know specifically how much a specific member has spent on a month on gas, for example. So this is a very interesting application that has been taking place in Chile. So here, towards the end of our presentation, I brought some cases on Hansard. As I mentioned to you, a number of parliaments are using it. Is the lowest hanging fruit for using AI in parliament. So here we have the House of Commons in Canada, the Senate of Brazil, the National Assembly of Angola, Parliament of New Zealand, Parliament of Estonia, Parliament of Netherlands, among many others. Here we have another case from Germany. Is one of the only cases of AI being used for counting votes, the German Bundesrat or the German Senate. Here is the project Caminar from Chile. It's a huge project. They have 3 different suites. Caminar L for a legislative assistant, Caminar A for administrative assistant, and under development they have also Caminar T for transparency. So they have all of these different modules. I'll just highlight one of the most interesting ones, Caminar L3, which contains an argumentation assistant, which provides a conscience-biased response for the member that asks for the assistance and the political and legal arguments to criticize or to support a specific proposal based on the political leaning of that particular member. So that's a very interesting case for colleagues to read, and I invite all of you to see a publication that we did specifically about this project. Here we have an older case from the US House of Representatives, the comparative print suite. that provides analysis and tracking of amendments to legislative proposals. Also, there is a publication on our website about this topic. This solution uses predictive AI and has been developed some 3 years ago, and it has reached its completion a few months ago. Here, the Brazilian Senate has a number of applications on generative AI as well. But the most interesting one is the procedural system that I mentioned a little bit earlier on our presentation. They created this assistant, and now other parliaments are trying to use it as well. Here we have the Watchbot from the EU Parliament, which uses retrieval augmented generation to retrieve information from their legislative archives for the public. If I may ask just 1 minute to conclude my presentation, if that's okay. Thank you. Here we have another case as well from the Chamber of Deputies in Brazil, the Ulysses project, which contains 8 different modules for different legislative services, coming from content on the website, to the managing of requests on the drafting office, ranging until facial recognition for the members to access the applications. Recently, they have developed the Ulysses U9, which was a chatbot to be added on the parliamentary website. However, after some testings, they decided to void that particular application. And here it's not about AI itself, but I thought about bringing this one as some food for thought, as many parliaments are having to consider physical upgrading to their structure to enable the usage of such new technologies. And here I brought the example from the UK Parliament. Specifically, this photo is from the UK House of Lords, where they are doing for many years restoration and renovation efforts. Here, to conclude, a well-structured modernization strategy in the Parliament can significantly improve parliamentary services, increasing the efficiency, the transparency, and the public engagement, as we have seen in these different legislative services. It's absolutely important to measure the impacts of the legislative modernization efforts. It must involve a series of evaluations on its implications and parliamentary principles. It's important to mitigate the risks of digital transformation to ensure the appetites of parliaments to use these new tools. Parliaments, they are not averse to innovation; they are averse to risk. So, how can we help them overcome that? And lastly, I would say a parliament must prepare for an actively promotion of these discussions on the impact of AI, both directly and indirectly on parliamentary operations. I say directly and indirectly because many times parliamentary officials said, okay, I have no interest on AI, but when we ask them, do you use WhatsApp? Do you use the Microsoft suite? Do you use a number of services that have AI embarked? So the institution is already using AI. Either they like it or not. So they should promote these discussions actively. And our contribution to these discussions have been to promote dialogues amongst different parliaments and publications and research around this domain.
Now we are going to pass over to Billy, who is the director of Tainan Sprout. He's going to walk us through the Tainan City Council Watchbot, a chatbot which aims to lower the barrier for engagement for citizens.
And hello, I'm Billy, and today I want to share our project named Tainan City Council Watchbot. And I'm the PM of this project, and also I'm a director of Tainan Sprout, and in a think tank in Taiwan named TICTeC. I'm a research fellow, and I'm an open source software worker and citizen journalist. And let me introduce the Tainan City and the Tainan Sprout. The Tainan City is the earliest city created in Taiwan and has been established for 400 years. And Tainan Sprout is a local NGO and located in Tainan City. And during the lunar year in 2016, devastating earthquake struck and causing a collapse of the Weiguan building in Tainan. And many young people who had returned home for the holiday, the lunar year, and stepped out as a volunteer to assist the disaster site. And afterward, these young people want to channel their collective energy to make a meaningful contribution to Tainan. So that led to the establishment of the Tainan Sprout. And for Tainan Sprout, the primary mission is to lower the barrier to participation in local politics. And as such, the City Council has always been the core of our work. And at first, we capture the public attention of editing and sharing the video clips of the City Council proceeding to highlight the key moment during the council inquiries. And you can see this is our YouTube channel. And at that time, we do a lot of the video clips. And in one instance, a councillor suggests that the police should avoid stop people from drunk driving within 100 meters from drunk driving with for their 100 meters of their home. Argue that many elder residents only drink nearby before heading home. His remarks angered many, sparking criticism the video's comment section. And at last, he was forced to issue a public apology. But for us, this video made us reflect, is the best way to hold the councillor accountable, or it is merely entertaining and attention-grabbing, and just make people want to bullying, and just want they to make it as a joke and not care about the politics. So, inspired by the GovZero's legislative UN voting guide, a project that used the open data to inform the public, we embarked on a similar initiative. With the help of the GovZero participant, DDIO, Tainan Sprouts make a large group of volunteers to clean and organize the City Council records, leading the creation of this site, the City Council Watch website. This platform allowed users to search for information about their district representative, including inquiries, proposals, and other legislative activities. But however, like many similar projects, these sites face a significant challenge. Many users didn't know how to get started or needed additional guidelines to find a specific information that they are looking for. So this year, we decided to take a different approach. We developed a chatbot to make the Tainan City Council's information more accessible and user-friendly. And here you can see we use the AI to digest the meeting records and make a live bot. We built a chatbot online, Taiwan's most popular message app, and by simply adding it as a friend, user can ask questions directly. And the chatbot supports multiple languages, including Chinese, English, and French, even allow user to ask questions via voice recording. So, what is this AI-powered chatbot can do? And it can present the overall performance of the City Council, compare the performance of the councillors, highlight the key point of the City Council discussions, and tell you which councillor work on the topic that you care. And we leverage the ChatGPT as the foundation for our chatbot. Its conversation capability make it effective and engaging. At the same time, we design a Q&A interface that align the user's nature and habits. Finally, I can share our development journey with you. And at first, we want to try to clean the council meeting data and put into the GPTs and then provide a chatting interface. But we facing a lot of difficult. At first, we want to make the chatbot, the AI can digest the meeting record as soon as possible. But we found that if we use the Whisper as the model to digest the voice record, because in Taiwan we are using the Chinese, and also there are some of the vocabulary that is really on the news, not in the database of the chatbot of the OpenAI ChatGPT. So what if we use the AI to convert the meeting audio into the text, it will make some misleading, and they are lack a lot of vocabulary and will affect the results that's the GPTs. But if we use the city council meeting transcription, it won't be released until it has until half years later. So at last, we use the PDF that they released at here, and we just take the only some of the part of the meeting record. We just put the meeting transcription that convert into the text. And another thing like the table or like the image, because that is hard to convert from the PDF, so we cannot use that. And also we put the information of the Tainan City councillors that people can ask the councillor that represents for their district. And also because of the problem that we're facing, so we go to visit the Tainan City Council, and you can see this is the speaker. And we ask them to make open data and to release more formats like the ODF or the DOCX. And they say they will release that kind of format later. So we do promote the open data. And then we put that into, if we use the GPTs as the interface, people need to pay to OpenAI to use our bot. So that is not convenient. So at last, we use the Assistant API and use the vector store that they support. And at last, and this is the interface of the Assistant API. You can see the system prompt is at here, and this is the vector store, and you can ask it question for testing. And at last, we provide the interface, and we use the line as the interface to provide more people can ask the question more convenience. So open source is really important. So we release our code on the GitHub here, and also the data that we're cleaning at here, so people can clean their own and make their own chatbot for their own project. And here I can share the live demo of the bots. Wait a second, and here, can you see the bot here?
Yep, we can.
So here are the questions. Please tell me which councillor in the Central Western District focus on transportation issue and which specific aspects of the transportation they are concerned about. So we can just send, and it will use the Assistant API to create a thread here and put a messenger in, and to run the script, and then because in the ChatGPT, it will release the information word by word. So you can see that here, this is the result, but it's in Chinese. So I think maybe we can record. Wait a second. And you can So
那个是生的，
wait a second.
这个红血蟹叠叠乐，
Oh, maybe it's let me try again. Okay, it is thinking. Ask me to waiting. Okay, so in before that we test the yeah, it's done. It's answered in English for now. So and also if because my phone is not nearby me, so I cannot record the video record my voice for you, and I'm really sorry. So in before that I do test to use the voice here, and it can use the voice to answer the question. So Alex, let me share back my screen. And here we got the English website at here, and you can see here are the usage, the guideline, how to use that, and what is the question you can ask. And there are instructions about what are the things that you need to be caution, like it cannot verify the numerical data like that. And here is, you can add the live bot. And here is the QR code that if you would like, you can scan on it and to add it as friend on the Line app and ask it question. So this is my presentation, and really thank you for your participation.
Finally, we are going to move on to Alex, who works here with us at My Society. Alex is going to talk about our work with vector search and They Work For You. Over to you, Alex.
Hi, everyone. Thank you for coming today. So today I'm going to talk a bit about They Work For You, our experiments with vector search, covering what this is, how it applies to our work, and what we've sort of learned from the process. So to start off with, just a bit, I've already covered the introduction side. Great, doing great already. They Work For You and our technical stack. So They Work For You is a UK parliamentary monitoring site covering the UK National Parliament and the devolved parliaments in Scotland, Wales, and Northern Ireland. It's 20 years old, which means it's built on an older tech stack, which all still works fine, but it also means it's had a lot of things bolted onto it over the years. The site does a number of different things. A key thing we think we do that adds value is search across the different parliaments, and especially our email alerts, which send people daily emails when particular people speak or when topics are mentioned. So last year, we received a grant from the Patrick J. McGovern Foundation to explore the impact that machine learning could have in our work. We've used this to understand machine learning better and also to think more about this problem of adding new bolt-ons to an old website, especially when we can't guarantee funding for proper maintenance in the long run. So what we're going to talk about today is the sort of free experiments we've done with vector search, how we're trying to get useful results out of this without making big changes to our ongoing infrastructure. So I hope this is useful to other people in a similar position of having a site that's been around for a while and sort of the corresponding cautiousness about big technological shifts without long-term funding for maintenance. So to start off, so what is vector search? So vector search is sort of a very useful byproduct of large language models that uses how they convert text into numbers to find similar concepts in different sets of text. So when language models are trained on large amounts of text, this sort of changes their internal shape so that text with similar meanings ends up sort of closer to each other inside the model. And so this vector, or sometimes called an embedding, is a sort of series of numbers that represents this location. And by looking at differences between embeddings, we can see different similar terms with similar meanings. So while a more basic text similarity in English would say that bat and bag are very similar words, a model that searches on meaning would identify bat and owl as nighttime flying things to be very similar. So this means without needing to retrain a specific data set, you can explore similarities between concepts. Different models get different approaches, and larger models produce more accurate closenesses, but there's also big efficiencies in very small models, especially in the embedding space. On top of this, a vector database is a way of storing these embeddings with associated index that speeds up the search. So in terms of building a vector database, there's sort of 3 steps. One is creating the vectors from the documents to be searched. There's storing these vectors in the database to be queried, and then there's creating the vector of the search term itself and query the database for nearest matches. So this might be used as the main way of searching or as a way of re-ranking results from a standard text search. The technical choices involved is deciding a model to create the embeddings and choosing that vector store to store and query the results. So the idea of standalone vector stores is part of the commercial AI offering, but there's also increasing bolt-ons available for the kind of relational databases we already deploy. So Postgres SQL, which the database provider we use for everything, annoyingly except they work for you, is the only one we don't use it for, already has a plugin available that can provide the right field types and indexes. There are similar projects in motion for MariaDB, SQLite, and DuckDB. And from our point of view, that means we should be cautious about solutions involving new stores or databases because it's pretty likely that techniques are available in ways that are compatible with our existing tech stack in the near future. In terms of models, these can be used to generate the embeddings and can be substantially smaller and easier to run than large language models. These can even be run locally using local GPUs or CPUs, which is a bit slow, but still fundamentally works fine, or on a remote service like OpenAI or Hugging Faces. Different models will have different performances in different languages. We chose to use an open model which could be run either locally or via the Hugging Face API. And the advantage of this for us is that we won't rely on a third party to run the queries in future if we properly invested in this. But in general, actually, our experience was converting our entire historical database. Actually, we only did about 10 years of it, but that only took like a few days of doing the analysis. So in general, the exact choice of model isn't a huge lock-in because regenerating all the embeddings in future would be easy to do. It's more than an hour, but it's less than a month, which is kind of like you can make a new choice there. Building the vector search, we used, to try approach using technology we often work with. So here, the Python framework Django and the Postgres database. Here, there's a PG Vector plugin that adds vector indexes to Postgres and a related Python package that makes it accessible for Django. So for anyone here who works in Django, like it looks pretty much like a normal model, but there's a new vector field in there and an extra index. As I was working, we're using GitHub code spaces and Docker containers. There's a Docker image that just gives you this PG Vector plugin over the top. So it's quite easy to work with for development purposes. From there, we went through 10 years of our transcripts, imported these into the database, and for each speech generated the corresponding vector to store that in the field. It was easy to drop and recreate the index rather than loading in the data as we went along. When we got to search in this database, here the steps are to create a vector of the search term, feed that into the search, and then I removed any that would have been picked up by a normal text search to understand what I was getting that was different. So for instance, one of the things I was interested in, like looking for debates around mental health. And here I was also getting matches around physical and mental health, mental well-being, mental illness that would be relevant to someone doing a search on those things. So it sort of validates that, yes, you can pick out things using this, but not be immediately clear on a standard search. The difficult problem here is it'd be difficult to integrate into our existing tech stack. And so we sort of explored 3 different ways we can use this approach without making big technical changes to a 20-year-old service. The first option was recent vector matches. So as a lot of the work here is creating and maintaining a database with a long history and a big index, we can just ignore this problem and we can just look at very recent matches. So like if we want to do a vector search on what happened in the last few weeks, we don't need to create a big database. We don't need to create an index to speed it up. It will work in 10, 15 minutes. So one of the problems we're interested in is picking up when MPs are declaring financial interests. They use lots of different words for this, so vector search is fundamentally useful. So what we have is a GitHub action that wakes up each morning, downloads the last month of database from the site, creates the embeddings, and uploads a list of matches for me to review. So this takes about 10 minutes for it to run, but it sits entirely inside GitHub's infrastructure. It doesn't bother our existing services, and it means we can then make new products like a newsletter that's based on the results of this without making big technical changes. We can in principle use this to enhance the email alerts without a database, but instead what we've done is use this database to make a lookup file to help people make better search choices based on past content. So loosely calling this similarity injection. So we have another site where we make UK local climate plans searchable. We had a data science fellow supported by a funder in for a few weeks. And what we sort of chose to do was rather than sort of integrate it directly into the site, we use the existing data we know about to find a list of similar terms and then suggest similar terms when people are making searches. So for instance, if someone's searching for solar panels, we know that results about photovoltaic panels is probably also relevant to them. And so without adding anything to the search, we add like a very dumb extension to the search that doesn't use machine learning components, but is influenced down the line by data derived from machine learning. So we're applying this approach to the email alerts and they work for you, working on a new flow where when someone makes a new email alert, we consult a list we've already generated from the database, like that previous mental health example, and ask if they want to include those terms as well. So there's no magic behind the scenes. It is just providing choices to people when they're making searches. So the advantage of this is that we're helping people make better alerts that cover more terms, but also the live technical side is very simple. It's just a big lookup. In principle, we can keep the list updated over time, but it still has value if you rarely do that. And this feels like a way that vector searches can be integrated into long-standing platforms without too much resource to change. After the initial work, which can be done in a bootstrap way by volunteer data scientists, there are no long-term infrastructure requirements. And loosely anticipating this will all get much easier the next few years anyway, and this may not be a good time to make a big shift. The option 3 is just building better parsers. So in a very dumb approach, sometimes we want to convert unstructured text into structured data. So for instance, one of the things I've been trying to do recently is detect motions people are talking about in parliamentary debates, so the thing they're actually talking about. In principle, generative tools like ChatGPT can do this, but what I found was it was relatively good at extracting emotion when I knew one was there, but less effective given a range of speeches that may or may not contain emotion. I think you can probably get it better at that by providing more source data, but also it was for like doing a big retrospective conversion, it was a bit slow. And so the approach I've taken is to sort of use this vector database to augment a traditional approach. Having identified a phrase that is like a motion start, like I beg to move, I use the vector search to identify other similar phrases that sort of crop up in similar places. And this sort of helps pick up a lot of historical variation and typos that make the final parser more robust. So the final parser is an incredibly dumb approach where it just looks for strings in the text, but it's influenced down the line from the fact we have this vector database as a tool for developers. So conclusions, vector search is a practical technology for PMO work. You still need to do some work, but there are approaches that can have big benefits without big infrastructure changes. The key to using it well is understand the problem you're trying to address, being cautious, providers trying to create lock into their tools, and generally being clear what the simplest approach to a problem is. Hybrids of old and new technologies may work well. So I'm happy to share a write-up of this after the call and can answer any questions at the end. Thank you.
Thank you so much to all of our presenters. Question for Luis. Which AI tools have proven to be the most useful and reliable?
Well, the answer, probably you're not going to like it, but it depends. It depends on first priorities of the parliament. So the most useful, as I mentioned during my presentation, the low-hanging fruit in regards to the simplest kind of platform to implement is the automatic transcription. Namely, the majority of parliaments are using Whisper from OpenAI to do that. But in regards to the most useful, it depends on how the parliament's tackling on their digital transformation. For example, the area that we see the most impactful implementation of AI, however, is one of the most complex ones, is on legislative drafting, because information produced by the drafting offices have an effect that usually is a downstream effect on different areas, namely on the parliamentary website, parliamentary offices, parliamentary committees, so a number of areas. So it depends on the focus that the parliament has, if it's on operational efficiencies, on business areas of the legislative process, or if it's on openness and getting a more friendly interface with citizens, promoting public participation. So it depends on the priority of the institution. Secondly, reliable. That's a very interesting question, and I would come back to the point of retrieval augmented generation, because parliaments have historically a huge database of human-produced high-quality information for decades, if not centuries. So, and for many years, this information was simply not accessible. I mean, it was in a scanned PDF or an in-paper document. Parliaments are starting to digitize these documents on formats that allow for its usage, its searchability, and using large language models like ChatGPT, Gemini, or even Claude. You can ground this data, we can ground these models on deliberative data using retrieval augmented generation, severely increasing the reliability of the information provided by the Parliament. However, it's imperative that all of this information, when it's produced by the Parliament, has a layer of human oversight. As I commonly say, the machine cannot be held accountable if a mistake happens, let's say in a transcription. It needs to be a person. And there is internal procedures for someone to be held accountable if a mistake such as this happens. So at the end of the day, the first draft or the first piece of information can come from a AI generated model or interface, but it requires someone with knowledge about the business area to review that. So not sure if I answered your question, but that's how we see these 2 points. Thank you.
Okay, the next question from the chat for Billy was, what are your experiences of the differences of underlying models in working in English and Chinese? I guess Mandarin or Cantonese, not sure which.
Yeah, we are Mandarin, and yeah, we still have some problem about using the Mandarin, and for one of the things is also the problem about the vector store. That's because the vector store that will just take a little bit of the information as a prompt to ask the bot, right? So sometimes if we want to ask for some stand question like who support for the Taiwan independent movement like that, and sometimes you will find a councillor that against that, but because the ChatGPT cannot distinguish what is the stand of that, so he will say that the councillor against the movement is support the movement, because I think that is because it is not good at the Mandarin. And also there are another things is while we using the vector store, there are still some problem. Like some of the content we are really know that in some of the meeting records, we got about 50 or 16 or 60 meeting record as in the vector store, but because somehow, I don't know, somehow it cannot give all the answer from the meeting records. Yeah, so I think there are still some problems about the Mandarin, but there are still a lot of, some of the problem is about the vector store. So I sometimes cannot distinguish that. Yeah, like if you ask for the attention rate of a counselor, and it will give you the wrong answer. Because in the vector store, it just can pull out some of the question, not all the, it just pull out some document, not all the documents. So it cannot count the attention rate of the counselor. So there are still some problem of that. Yeah.
I have another question for you, Billy, here. How has the app been received by the actual councillors? Do they like having their records so easy to scrutinise?
We do has a log of the, we put the chatbot on the Google Cloud Run, and we do have a log, but the log is only for debug, and we cannot know who sent this message to us because, well, if you use the Lines Developer SDK, it just only can give you a random ID of the people who talk to you. So you cannot track who is the people. But because we need to know that does the chatbot give the wrong answer? So sometimes we need to log that just for debug usage.
Do you have usage numbers for the chatbot, i.e. how many citizens are using it?
I just searched for the number, and we just released the chatbot for 2 months, and there are about 200 friends the citizen at that and ask a lot about 1,200 questions. And also because we released the bots, so there are another city's local group. They are interested in learning how to use this kind of bots. But there is a but. We do count of the cost that each of the problem about 20 or 30 question to ask the bot will cost $1. So it's for the local group, sometimes it's a little bit expensive. So this is still a problem that need to solve.
Thank you so much to all of our presenters for your time and your contributions.